After ChatGPT became popular, many media and people in China panicked. All of a sudden, all kinds of media, especially we media, are full of articles such as why China didn't give birth to ChatGPT and a new technological revolution is about to break out in the US. Many research institutions and companies have announced that we are about to launch our own ChatGPT. Many people feel that ChatGPT has brought new opportunities for themselves. In fact, such a national refining ChatGPT is neither necessary nor possible. Why is this? It's not necessary. We will slowly develop it later. In this lecture, let's talk about impossibility first. As we mentioned earlier, the core of ChatGPT is the language model, and the language model needs to be trained with a large amount of data. After having the data, it also needs powerful computing power support. And then it needs to have a high enough level of parallel computing and machine learning algorithms. Data, computing power, and algorithms are three hurdles that only very few internet giants can cross. Next, let's look at these three aspects separately. Limitation 1. Data. Let's start with the first limitation, data. Back in 2012, when I was training a model for automatic question answering at Google, I used almost all high-quality data available on the internet. Today's ChatGPT uses more data, especially data from Media and social networks. This amount of data is extremely large. Not every business can get all of this data. Limitation 2. Hash rate. Moreover, even if a company can obtain this data today, it does not have the ability to store and process it because the computational load of processing it is too large. This brings us to the second limitation of training language models' computing power. As mentioned earlier, the early algorithm was very simple, which was to do some statistics on the text, and then use some simple mathematical formulas to calculate the probability of a word under different contexts and save it in advance. When used based on these probabilities, calculate the probability of various language phenomena, such as the probability of a sentence, or the probability that a word is a noun, or given a question, the probability that a sentence is its answer. This was the method until the 1990s. At that time, even doing such a simple statistic consumed a staggering amount of computing power that only large companies like IBM could do. But soon, Ulinic and others discovered that if they just performed simple statistics on text, no amount of data could cover all language phenomena, and for many language phenomena, especially the probability of language phenomena that had not been seen before language, the model estimates are very inaccurate. Therefore, people began to consider deep mining of the information contained in the language, including grammatical information and semantic information. This requires a larger amount of computation. How much does the specific calculation need to increase? 1 million times to 100 million times is a reasonable estimate. Many people think that Moore's law can make the cost of computing continue to decline, and things that could not be done in the past can be done today. In fact, with the passage of time, people's requirements for artificial intelligence are also increasing, and the required computing power is also increasing. Computing power is always a bottleneck. In the late 1990s, Ulinic applied for a grant from the US National Science Foundation (NSF) for us to build complex language models. At the same time, machine learning around the world has also made breakthroughs in algorithms, allowing us to train more accurate language models. In addition, Ulinic received a huge grant from the US Department of Defense, allowing us to equip hundreds of super servers. With the help of these devices, we were able to improve language models that other research units were not qualified to do. In 1998, I attended an important academic conference of the IEE, the Institute of Electrical and Electronics Engineers. The presentation before me was given by a well-known scientist from Germany, who concluded that better machine learning algorithms did not seem to be effective for improving language models. My subsequent report rejected his conclusion. Our research shows that better machine learning algorithms are effective, but require a long time to train until the model really converges. We could mobilize about 100 times his computing power at the time, so we can do what he can't do. But even though we had the best computing power in academia at the time, many of the things we wanted to do were still impossible. When I tried to add all kinds of grammatical information to the language model, I found that with our computing power, it might not be enough to do this in 10 years, and I wouldn't be able to graduate at all. At that time, we saw an IBM scientist do something similar and published an article. So we asked him to give a report and wanted to know how he did it. In fact, what's really remarkable about him is not that there is something unique in the method, but that he wrote a program that took the idle servers in the entire IBM Watson experiment and calculated it for an entire year. We also talked about this earlier. Later, my mentors wanted me to surpass this scientist, so I spent half a year mathematically improving the algorithm, reducing the computation required for training by a factor of 200, and then running it on 40 super servers for 3 months. Finally, I trained a language model that was the best in the world at the time. Without this 200x improvement, I would have needed to calculate for 50 years. This example is not to say how great I am, but to let you understand the importance of computing power to machine learning. You see, even if the algorithm was greatly improved at that time and the amount of computing was reduced, it still required 40 super servers to run for 3 months. The language model used in ChatGPT today is 100,000 times larger, in terms of the number of parameters than the model I trained at the time, and 1,000 times larger than the model I built at Google. The computing power required to develop it is not only 100,000 times that of my Johns Hopkins time, but probably tens of billions of times. Today, OpenAI, the company that develops the GPT language model, does not say how much computing resources it uses, but it hints that the hardware cost is more than $100 million. If we calculate at $1,000 per GPU, it uses 100,000 GPUs. Based on 32-bit computing, it can provide over 100 flops of computing power, which is more than 1 billion operations per second. This is twice the computing power of the entire Tesla cloud service cluster, a third the computing power of Google's largest data center, and a quarter the computing power of Alibaba Cloud Allianz's largest data center. This is only the cost of developing GPT-3. When upgrading to GPT-4, it requires even more computing resources, using a large amount of computing resources from Microsoft Cloud Service. Even so, ChatGPT recently closed the registration of its paid users because providing a better service to paid users was too computational. Therefore, if you also want to make a ChatGPT, you must first consider whether your computing power is enough. Many people feel that opportunities have come when they see a new technology, but most of the time, those opportunities have nothing to do with everyone, because everyone does not have the basic ability to implement it. Limitation 3. Algorithm. So, if we take the national effort to build a few supercomputing centers, is it easy to surpass ChatGPT? If you only look at the computing power, it seems to be possible. But in fact, computing power is also divided into smart computing power and stupid computing power. For artificial intelligence problems, only the former smart computing power is meaningful. The so-called smart computing power means that computing power alone is not enough. You have to have supporting algorithms to maximize the effect of computing power. If there is no supporting high-quality algorithm, computing power can only do twice the result with half the effort. This is stupid computing power. This brings us to the third limitation of training language models algorithms. In 2000, when I was building a language model at Johns Hopkins, I was able to mobilize 40 servers at a time. There was no cloud service at the time, and I relied on a parallel computing tool provided by the University of California, Berkeley. This allows me to avoid manually monitoring the work of each server and automatically assign tasks to idle servers. Later, with cloud service, this matter became much easier. However, today, the machine learning algorithms used to train language models are much more complex. In 2010, Google launched a tool based on the cloud service platform Deep Learning Google Brain. Using this tool, the effect of language models can be greatly improved. Other things being equal, the relative error rate of automatic speech recognition and machine translation can be reduced by more than 10%. Today, the underlying algorithms of deep learning and the infrastructure that supports it are standard in intelligent data centers, sometimes referred to as smart computing platforms. If you just train the language model with a data center stacked by processors, including GPUs, the results will be much worse. In other words, in addition to computing power, the basic natural language processing technology, that is, algorithms, is also an indispensable condition for implementing ChatGPT products. In the most intuitive example, you want a computer to answer a question, or at least understand the question. You want it to know what might be the answer from hundreds of billions of texts. You need to match the question to the answer. This job is not done in a year or a half. Today, many machine learning algorithms have been open source, and some applications have been developed by companies and research institutions, such as basic graphic recognition and automatic speech recognition technology. But deep natural language understanding does not belong to this category. The accumulation of technology in these fields is actually a resource. Therefore, some companies that have invested in this field for a long time, such as Google, Microsoft, Baidu, ByteDance, etc., in China, actually have accumulated certain technologies. They may integrate existing technologies in a relatively short period of time to make products similar to ChatGPT. However, for those who do not have the necessary technical resources at all, following the trend of ChatGPT is either ignorant fearlessness or hype. As we said earlier, in addition to processing natural language model technologies like GPT can also find application scenarios in many fields, such as in the biomedical field and video editing, which require corresponding algorithms, so we will not list them here. Therefore, there are not enough algorithm resources, and it is not recommended that everyone build ChatGPT.